Okay, hi everyone. So today we're working on graphing fractions, and the fancy word for fractions is rationals. Rationals. And rationals are kind of very similar to us graphing sine and cosine. There's just a couple of things we got to pay attention to, right? And we have some rules that we want to follow that will help us figure out what these graphs look like without really that much work. We almost will never need a calculator to graph these. We will almost never need a calculator to graph these. And we're going to talk about some specific parts and how to graph it. But today we're going to focus on one main thing, and that's what we call vertical asymptotes today. So we're going to focus on vertical asymptotes. So let's go ahead and get started. And let's talk about easy graphs here. If I just say y is equal to x. Now what a graph is, it's all the possible points. If I plug in -1, 0, and 1 here, if I plug in the equation y is equal to x, which is now -1, y is equal to 0, and then y is equal to 1, right? That's what we're plugging in. So y would equal to -1, 0, and 1, because we're plugging in this function. And then when we graph it, we graph our x's and our y's. 0 is 0, 1 is 1, and -1 is -1. Okay? And what we do is we just kind of interpolate. We just kind of figure, oh, between this point and this point, there's probably a bunch of points in between. So we just draw that line. And for a straight line, it makes sense, all right? But for a graph like a parabola or anything else, we're just guessing, right? Example is if I tell you, drive from here to downtown, right? You have in your brain, you're going to hop on the freeway, drive to downtown, and get off at some exit. But a bird would fly across everyone's house, right? A plane would fly across. If you were on the subway, right, you would have to drive to the subway. There's a lot of different ways of getting there, but at least you have these 2 points. And what I mean is these 2 points are the most important points for us because we know for sure those are it. And we just gotta guesstimate our way, get our way there. Well, we were graphing before, we were doing something like x squared plus 6x plus 8, and this is an easy problem, but we said if I factor this to be x, 4, 2, plus plus, we said, hey, if I find the roots of this graph first, that would make this problem a little easier. So we said if x was -4, if I put -4, that would become 0. And if x was -2, -2 would make this go to 0. We have at least 2 points that we could say for sure are true. -1, 2, 3, 4. Oops, sorry, that's not -2. -2 and -4. And then we use a lot of skills in our last test about higher order polynomials. In this case, I'm just using this easy example, but we would say, hey, what's the end behavior of this graph? What would the graph look like over here on the right side? So we said, looking at the largest exponent, okay, what is a positive times a positive on the right? And on the left, what's a negative times a negative? Because of this x squared. Oops. Because of x squared. And a positive times a positive would stay positive. So on the right side, we're for sure going up. On the left side, negative times negative, still positive. So we'd be also going up. So what happens between here and here? We can just guess. You know, it could go this way. It could do a bounce. It could go down here, have a party and come back up. And what we did is we said the idea of multiplicity. We added some details based on rules. So the multiplicity, what's the multiplicity of -1? Oh, -4. This happens only once. And the multiplicity of -2 happens only once. So as I approach here, -4, we said since the multiplicity is odd, we are going to cross. Next stop is -2. At -2, we're going to cross. So we can get a nice approximate look of what this graph would look like. We make the problem look a little harder. Y is equal to, I'm going to do a factored version this time, x minus 2, x plus 2, and x minus 5. What would this graph look like? I could multiply it together and give you this crazy polynomial. But let's go ahead and look at the roots. The roots would be 2, -2, and 5. 1, 2, -2, and 5, 3, 4, 5. These are the roots to my graph. -2, 2, and 5. This was going to be an x cubed problem, right? X gives me x cubed. So on the right side, a positive times positive stays positive. We know we're going to go up. A negative times negative times negative. End behavior on my left is we're going to be down because that's a negative. So what values are in between? Well, does the graph go simply like this perhaps? And we had a trick that we learned on last homework is that, hey, or in my last chapter, is that if the multiplicity is odd, again, and these are all odd, we're going to cross, and cross. The idea here is I'm not doing any math to graph it. I'm using some characteristics that we have learned through some rules to help graph it. And that's what we're going to do for our next set of shapes. We're going to graph rationals. So rationals look like this. 1 over x minus 1. It's a fraction, an f in fraction. F for fraction. Now, we are going to cheat slightly, okay? We're going to have a whole set of rules to do these, but we're going to slightly cheat. First thing, I'm going to ask you, what are the zeros, not of the top, but zeros of the denominator? And those are one of the most important parts of these graphs. Now remind yourself, why do I want to look for the zeros of a denominator on a fraction? And is there a rule that we have that talks about the denominator of a fraction and it being 0? Can I make a fraction become 0 on the bottom? And the rule is that this is undefined. If you remember, whenever you try dividing by 0, that becomes what we call undefined. Undefined for us is, I mean, in English, what does undefined be? Why do we say, instead of saying no answer, we say the word undefined instead? And oftentimes in algebra, you learn the word no solution. Why can't I write no solution here, and why do we write undefined? Well, I want you guys to think about a dating relationship. Not even a dating relationship, just a boy and a girl. And this boy and girl, they've gone on a couple of dinners and movies. This is pre-COVID, okay? Pre-COVID. These days, COVID, they've gone on a couple of Zoom dates, okay? I mean, Zoom meetings, right? So eventually, let's say they've been hanging out for 3 months and they haven't talked about where this is going. Isn't it kind of undefined? Huh? Isn't it a little bit awkward now? It's been a couple months. We're friends, we're a little more than friends, maybe a modern romance. So the idea of undefined means it's kind of eh. Now, the reason why it's called undefined is because 0 doesn't go into 1. And why doesn't it go into 1? Let's see, where is it going? So let's go ahead and take a look at some values that we do know. If I divide 1 by 2, that is easy. That's going to be 0.5. Looking at decimals. If I divide 1 by 1, that's going to be 1, because 1 goes into 1, right? So I'm going to go on this really long line here. I'm going to see what happens as I get closer to 0. What happens as I get closer to 0? And that is the big question is, sure, everyone my whole high school life has told me you can't divide by 0. You can't divide by 0. Don't do it. But why? And why is it undefined and not no solution? Because I'd rather just say no solution. This is stupid. But it's undefined for a specific reason. And let's go ahead and keep going. I'm going to divide 1 divided by 0.5. Now if you take a look here, let's go ahead and look at my map here. My graph is 1 over x. This is not the graph that we're looking at, but 1 over x. And if x was, let's look at it. If x was 2, 1, 2. Well, I'll make this a little better. Make it a little bigger. Here's 2. My y value would be, it would be 1/2 right here, okay? If x was 1, if x is 1, my answer would be at 1. If x was 0.5, now take a look here. I am walking toward 0, headed home. I'm headed home to 0. What if x was 0.5? How many 50 cents? Isn't 0.5 50 cents? How many 50 cents are in a dollar? There are 2 50 cents in a dollar, right? So at 0.5, we're at 2. How about at a quarter, 0.25? How many quarters are in a dollar? That's 4. So as you can see, we are actually headed 0.5, and then right here is 0.25. So remember, we're trying to get closer and closer to 0. We're trying to peek what that will look like. How about at 0.1, 10 cents? How many 10 cents are in a dollar? Well, that's 10 already. Oh crap, I can't even graph it anymore. How many nickels are in a dollar? 20. How many pennies are in a dollar? If you look at the values as x is getting closer and closer and closer to 0. This is like what I'm looking at GameStop, right? The GameStop prices keep falling. Oh my gosh. Okay, or Dogcoin, right? And what happens is this graph, as we head this way, it actually starts taking off to, guess where? It's heading off toward infinity. And what happens is, as we get closer and smaller and smaller, get closer to 0, and our denominator gets smaller and smaller and smaller, 1 over 0.001, that's 1,000th. 1,000th. How many thousandths are in 1? That's 1,000. So if you look here, as I get even closer to 0, we are headed to infinity. Now the reason why the answer to 1 divided by 0 is undefined is because infinity is not a number. It's more of a idea. Because you can't really say count to infinity. Like, what's infinity? It's this abstract idea. It's like me saying I want to be rich. What do you mean by rich? If you have 10 bucks, you're richer than you were yesterday. Here's 10 bucks. You're wealthy now. But when we use these words like infinity and rich and wealthy, they're kind of abstract. And there's a number that you might be thinking about, but even then it's a little lofty. Now, infinity for us is the same idea of the word rich. What does that really mean? It means beyond any number you can think of. And when we say infinity, we really mean never ending. So why is 1 divided by 0 undefined? Is because and now this is the pre-calculus talking in me, the limit as x gets closer to 0 of 1 over x, the answer is infinity. Meaning, as we get closer to 0, as x gets closer, gets smaller, this number is going to shoot up to infinity. Now, I'm going to go ahead and give you guys another example. And it was my birthday recently, and I turned 40. Yay, Mr. Co, old guy. Okay, and let me draw my cake a little bit differently here. Here we go. No, that's not a cake, Mr. Co. So here's Mr. Co's cake. And I didn't get a square cake, I got a round cake. Actually, you know what? I didn't even get a cake. I didn't want a cake. I made a big point, big stink of not having a cake. I don't want a cake. No one get me a cake. And then, of course, it's in my part of town, you find a lot of Asian cakes. And then, so let's make this a little bubbly here. Hello, wow. Look at that frosting design. Happy birthday to me. Okay. So I'm going to ask you this question. How big of a slice of cake do you want? Okay, so how big of a slice? And what I mean is, I want you guys to tell me in a math way. Okay, do you want half a slice, half a cake? If I ask for half a cake, how many slices can you give? You can give a total of 2 slices, right? If I cut this cake in half, you got half the cake. Okay, what if I ask you for a quarter of the cake? 0.25. See, isn't this a quarter of a slice? You guys see this is a quarter of a slice? How many slices can we have now? 4. Oh my gosh, you guys are pigs. What if I ask you for a tenth of a slice? Okay, if I want a tenth of a slice, we got to cut this up even more. I need to get rid of the last 2 ones, I think. I would ask for, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you guys get the idea? I can give you 10 slices. But the smaller of a slice that you want, the more cake I can give people. Anyone ever have a big quinceañera and you guys had a big cake that you guys had to cut up? And if you guys have a lot of people, either you have a super huge cake, or everyone gets a small tiny slice. So the idea is, if I ask you for a 1,000th of a slice, okay, you can give 1,000 slices. Now, what if I ask you, hey, I want 0 slices of this cake. I want 0, okay? Oh, whoops, sorry. I want 0 slice. Hey, here's your cake. I want 0 slice. If I cut this cake into 0 slices, how many slices can I give people? How many people can I feed with 0 slices? I can feed the whole freaking world. I can feed everyone because I'm never cutting into this freaking cake. If I cut this by a small tiny 1,000th of a slice, sure, I can feed 1,000 people, but I'm going to run out of cake eventually. But if I say nothing, air, how many slices can I give? I can give as infinitely many slices. Everyone gets a slice because you got nothing. And that's the idea here. The slices are so small, I end up with infinity. Now, why is that important? Because let's go back and look at my original problem. We said 1 over x minus 1. And our fear is that we do not want to divide by 0. But that is actually a special, super special thing about this graph. Now, if x equal to 1, do you guys agree this would kill it and we would become 0? Now, this is what the graph will look like. When x is 1, here's 1, we have what we call a vertical asymptote. And the graph will spin around 1. Okay, what I mean is, you guys ever watch a Fast and the Furious? And then there's always like a bridge that's up, right? And then they have to drive up and they have to jump over this bridge. This is almost like that bridge, where except this bridge is more like you just take off to infinity. You come back down from infinity. Why? Because at 1, this graph doesn't exist anymore. Because at 1, x equals to 1, the graph shot off to infinity. Now, I'm going to show you some stuff from Desmos, which is going to be kind of cool, hopefully. And it'll help us kind of solidify what we're kind of talking about here. So I'm going to give you guys 1 divided by, I will say x minus 1 like we just did. Okay, and you can see at x equals to 1 here, we have a, I'm going to change the color of this. Oops. Make it dotted, and then I make it actually slanted, and then I'll make them a little orange. Okay. Now, I'm going to do something. I'm going to change this number around. I'm going to stick another variable here, and we'll say the variable is going to be the letter, let's use the letter A. Okay, add slider for A. Now, if you want to look here, I'm going to start walking the A back and forth, okay? See all that? I want to change some characteristics of this, because I want to step by 1 to make it easier on us. step by 1, and we'll go from negative 10 to positive 10. And then I'm going to switch this variable just to a so we can follow along. Oops. X equals to a, wrong one. X equals to a. Alright, here we go. So if you look here, as I walk around, as x changes to become positive or negative, the vertical asymptote follows along with me. So what does a graph of 1 over x minus 3 look like? Okay, y is equal to 1 over x minus 3. Remember, f of x and y are the same. That's why I'm interchanging them. Well, at x equals to 3, remember, 3 makes us go to 0. 3 is not allowed. No, it's infinity. So at 1, 2, 3, we're going to always draw a vertical asymptote. And our graph is going to be on the right and on the left. What if it's y equals to x, sorry, not x, 1 over x plus 3. Okay, what makes this go to 0 now? Take a look here. What would make the denominator go to 0? When x is negative 3. One, two, three, negative 3. And we are going to infinity there. And the graph will look like this. What if I had two different zeros? What if I wrote y is equal to x plus 1, x minus 1? What numbers would make the denominator go to 0 here? The numbers that would make it go to 0 is negative 1 and positive 1. Are you guys okay with negative 1 and positive 1? Okay. Because if I plug in, that's a negative 1. 1 over negative 1 plus 1 and negative 1 minus 1. This would still be 1 over 0, which means it's undefined, which means we're going to infinity. Well, here's the cool part. I can graph this in a matter of seconds, okay, with a couple of rules, but this is our basic 1 and negative 1. We said we're not allowed to be here, so I'm going to draw vertical asymptotes. Now, the rest of the graph will look probably something like, something like this. Okay? But we will work that out later. The skill that we are learning today, only one skill that we're working on. It's what are the zeros? What values would make the denominator go to 0? Right here, what would make it go to 0? And what would we call then our vertical asymptotes? Okay, I'm going to show you guys this graph over here actually. Let's go ahead and rewrite it. I'm going to change the denominator to become parentheses, open up another parentheses, and then x plus a So if you take a look here at my graph now, as you can see, there's our two vertical asymptotes now. Okay, there are two vertical asymptotes now. So the number of values we can make go to 0 on the denominator leads us to, at least initially for this first part of our lesson, to go to also to become a vertical asymptote. Now the rest of the graph here, how do I know? Let me go ahead and oops. Let me go ahead and do one more thing. I want to show you guys something here. Oops. How do I know? See, those are my vertical asymptotes. Now, how do I know what happens here, here, and here? Okay. Also, what happens here, right? That's what we call a horizontal asymptote. How will we find that out? That will all be discussed the next time I see you. All we're doing today, the main takeaway is this. What are my vertical asymptotes? Okay. Now the next part of this is talking about domain and range. What is the domain and range? And what domain and range are referred to as we first start right now? It's domain and range. Domain, let's write this out. The domain and range. This is our x and our y values. Okay, what x value are we allowed to use, and what y values do we receive? Okay, what x values do we use, and what y values do we receive? So if I give you a problem, let's go ahead and start writing in regular pen now. The domain is my x values. Let me ask you, if I write y is equal to 1 over x minus 1, what values do we say we could not use in this problem? We could not use what number? X is equal to 1. We could not use it. Why? Because if I plugged in 1, the answer would shoot off to infinity, and infinity is not an answer, is not a number. Infinity is not a number. That is not an answer that we are going to accept right now. So what x values are we allowed to use? We can plug in -2, +2, -3, +3, -4, +4. We can put any number except -1. So the domain here is going to be written as I can go from -infinity to 1 and from 1 to infinity. That's how you guys are going to have to state your answer. What happened here? We skipped 1. You might have seen this answer before, from -infinity to infinity. This means all answers okay, right? All the answers are okay. If you go from -infinity to infinity, that means you went from one side of the map all the way to the other side of the map. But we said that we are not allowed to use 1, right? So we're going to take a pause. You guys ever hop on a bus, get off the bus and hop on another bus? Why doesn't that bus take you all the way through? Because that route doesn't exist. There is no one bus to do that. And that's what happened here. There is no one function that covers everything on this graph. We have to stop at 1 because it doesn't exist there. So we stop at 1 and then we continue. Now let's look at another problem. If it was y is equal to 1 over x plus 2 and x minus 3. Go ahead and look here and tell me what are the zeros that I am not allowed to use. Which x values am I not allowed to use for this problem? We're not allowed to use -2 and 3. Are you guys okay? We're not allowed to use -2 and 3. Well, if I'm not allowed to use -2 and 3, what happens? Well, on the graph, at -2 and 1, 2, 3, they don't exist because we have a vertical asymptote there. We have a vertical asymptote there. So how are we going to write our domain? So the domain is from -infinity, we start all the way on the left, to -2, stop, from -2 to 3, stop, and then from 3 to infinity, stop. And this looks super confusing when you first learn it. But I'm going to show you on the number line why it's not confusing. If you remember on your graph here, don't we draw arrows to mean it keeps on going? So where does this arrow go? It goes to -infinity, doesn't it? So from -infinity all the way to -2, that's this first part of the graph. Take a look here. From -infinity all the way to 2, that's the first part of the graph. But we don't go from right to left. In America, we read from left to right. So from lowest to highest, we're actually going this way. So from -infinity to 2. What's the next part of my graph? Well, isn't the next part of the graph right in between -2 and -3? So from -2 to 3. -2 to 3. That's my next domain. And the last part of the graph, where does this value go? It goes from 3 all the way to infinity. I feel like that's a lot easier to look at than me just showing you guys this right here. But if you look at a graph and you see what parts am I allowed to play at? We have 3 different parts. The left, middle, and the right. The left goes from negative infinity all the way, stop at 2, get out of your bus, hop back on the second bus that goes from 2 to 3, then hop off again, and then hop from 3 to infinity. And that is our idea of domain. What values am I allowed to use? And again, why can't we use it at negative 2 and 3? Because at negative 2 plus 2, that would be a 0. And no, we cannot divide by 0. At positive 3 minus 3, oh, that's 0 also. We cannot divide by 0 because that is not a number, that's infinity. And at these points, the graph is probably going to shoot up to infinity or to negative infinity. Okay. And this is our first big jump into graphing rational functions. And you might have learned this in Algebra 2 on how to graph these graphs that shoots off to infinity. But the reason why we describe this as undefined is not because there is no solution there. It's because the solution is so big it doesn't make sense. It's infinity. It's like talking to a child. Okay, it's undefined. Okay, all right. So today's homework, you guys are working on My Open Math. Okay. Hi, we're back. We're working through some of the questions on the homework. So the question is number 2. What's the vertical asymptote of the function? Remember, are we dealing with the top or the bottom? The top or the bottom? It's all about the bottom because we can't divide by 0. So what number would make this go to 0? X plus 2. Negative 2 would cancel out the bottom. Check that out. The answer is just negative 2. You have to write x equals to negative 2. Remember, you're allowed 3 tries. What's the vertical asymptote of this function? X plus 9. You can probably guess. What cancels out with a plus 9? A minus 9. That's right. Okay, so those are our first sets of questions. The second one, kind of weird. Same thing, same idea here. X can't be what? X can't be negative 7. X can't be what? Negative 8, right? We don't care about the top right now. We don't care about the top. We'll learn about the top later. We will learn about the top, but we're not worrying about it right now. I just want to make sure you guys can spot what would make the denominator go 0. What cancels out with a plus 4? You probably guessed it. Negative 4. Oh, look at that. Let's jump to 9. 9 is going to take you a little bit more work here because it's x squared minus 81. Can you think of what numbers will cancel out with 81 when I square it? Probably guess it. 9 and negative 9. And they want you to also write that out here. But they want you to write the smaller value first, right? Enter the smaller value first. So not only this is a logical step here, we're saying what values do not work. They do not work at negative 9 or 9. And that leads us to say, because they don't work, they are now vertical asymptotes. They're gonna shoot up to infinity. Goal. Okay, wrong sport. X squared plus 9x plus 14. This one's a little harder because we have to factor it. What two numbers multiply to become 14? 2 and 7. And 2 and 7 do add up to 9. So let me go ahead and take a screenshot here real quick. Remember, I do not care about the top right now. So our values are negative 7 and negative 2. These are the values that are not allowed here because that would take us to 0 on the denominator. So our answer is negative 7, negative 2. And that says, hey, that means my vertical asymptotes are at negative 7, negative 2. Negative 2, negative 7. Make sure you write the smaller value first. My goodness, Mr. Ko. So you have to be able to factor 2 numbers multiplied to become 56, 2 numbers multiplied to become 2 here. Now, the last part was about domain, and I want to make sure I gave you guys some chances to practice domain, because domain is always a tricky one. Now, let's go ahead and write this out first, and we'll see if we can get it. So making this go to 0 is negative 8. You guys agree? X cannot be negative 8. I'm pretty sure you guys all agree with that. So we're going to go, let me just show you the number line here. Here is negative 8. And we have negative infinity and infinity. So the graph goes from negative infinity to negative 8, stop, take a break, and from negative 8 to infinity. Right? That's where these graphs cover, and we have a vertical asymptote right at -8. We skip that. And we take a look at our answers. And as we said before, we write negative infinity. They want you to write this u as a union because it's either or. Okay, it's either or. It's A or B. Okay, and the same thing goes for these. Let's do this one over here. They want you guys to use the union. That's fine. We said it can't be 7 or 1. Oh my gosh, that was too fast. Mr. Ko, slow down. But that's what I'm looking for automatically when I see these problems. What values don't work? 7 and 1 don't work. Okay? Now identify the domain. The domain goes from, okay, I need a number line here. Here is 1. Here is 7. We go from negative infinity all the way to 1. Oops. All the way to 1. Then from 1 to 7. And then from 7 to 11. I'm sorry, 7 to infinity. And they want to write a union in between. Okay, so it's or. Right, so I'm going to write that there. Okay, and that's pretty much it.